Let's see. So yeah, I'd like to thank Vikram and Fabric and Symantec to organize this. So it's a great event for friends and people who like OpenFlow SDN to get together. So I released it, a bunch of my friends, my old CEO Harry, actually a couple of my customers. So today, let me just say this. So let's focus on the working part first, right? All your bugs and things need to be fixed. We'll talk about that tomorrow. Like Vikram said, I think about a year ago, James and I gave two presentations. I gave a presentation, I brought the PKA white boxes to the Hacker Dojo. I kind of run through how to configure the Open vSwitch on the hardware, how to set up flow, how to configure bridges. I think I remember I brought my Linux laptop with a USB bridge and some USB to Ethernet cable, run Wireshark, send packet, set up a couple flows. So since then, I think it's about exactly 1 year ago. Now, actually, we have a couple customers actually take the OpenFlow switches into deployment, and number of flows compared to the one in the demo, I think I had 4 flows I configured. Then they have like 1,000 flows, close to 2,000 flows running in different tiers of switch. So today I will go over that. By the way, if you have questions, just raise your hand. You don't need to wait for the end. Make it as interactive as possible. So here's the topics. I will go over that. So first, go through some marketing on the PKA. So if you don't know PKA, or if you may heard people call it PKA different names, right? So we've been called like a white box vendor. Actually, we're not. We don't manufacture white box. I remember went to a customer, sit down. The first thing they said is, "We're looking for a dumb box vendor that put a dumb network box into our network." So I responded, "Yes, we do produce dumb boxes, but it took a team of very smart people to make the box look dumb." So we are actually a software company, even though today we bundle our software on white boxes, we sell switches because the white box market, we don't think it's mature enough to have that model. You buy white boxes and buy software. But one day we'll be there. I know there are companies working in that model. So we are a software company. We have 2 stacks on our platform. It's a Linux platform, and we support layer 2, layer 3 stack, our own software. A couple of years ago, we bought Zorp. It's an open source layer 2, layer 3 stack. And since then, we changed a lot of stuff, make it production ready. Then we have OpenFlow stack. We use the OpenFlow vSwitch. We put an OBS virtual switch onto the hardware platform. Right? We take out the kernel module that do flow manipulation inside the IP stack, but we put it on the actual hardware. The vSwitch version in the current release is, the source code is 1.9, that we support OpenFlow stack version 1.3, and we're in the transition of porting the 2.0 source code, which has multi-thread support and a bunch of improvement, and trying to support OpenFlow 1.4 in Q2. Okay. So today the focus is really on the OpenFlow stack, and the number of lines of code between the OpenFlow stack and the layer 2, layer 3 stack is huge. I mean, it's really few percent of the code size. So make it very slim, very easy to improve. That's why we have very fast releases. Okay, so these are the platform we're offering. I won't go over the details. So today, I will talk about the story that we took those platforms from the lab into production. Okay, so last year we have probably over 200 customers who bought our switches, but very few deployments. Okay, so there's reason for that. So hopefully through today's discussion, I will share some of the issues and hopefully people who is interested in going to OpenFlow deployment, they will go out of the lab and go into production. Okay, so hopefully this presentation will help you to make those decisions and understand what it takes to go through those deployments. Okay. So this presentation is about a customer we have, and they want to design a greenfield data center, okay, in New York, support Wall Street applications. And they want to have a pure OpenFlow design. Right? Very hard to find people who take that plunge and say, even though I have all these constraints, but I want to work through the constraint because I know I can benefit from a white box and OpenFlow switch platform. So they went through the whole design development cycle, and we're kind of step by step with them. So today I won't talk about the server, the VM, or the other part. I'll just focus on the network design. Okay, so it's a greenfield white box data center. Then day one, when I met with their team and the CEO, they said, I don't want to have any legacy in the data center. Okay, no protocols, no nothing. I just want a pure OpenFlow control network. I said, great. There's no flooding. I'm sorry. V6 is not supported right now. Okay. No, their network does not support V6, but ours will support V6. But if you want to run V6, there's some limitation in terms of TCAM, number of TCAMs you can do because they two entries. Okay, floodless network, no flooding, no multicasting, no broadcasting. They want to have very simple control. Simple, but they want to have complete control over the entire data center. They want to control the IP address scheme. Okay, they want to control the forwarding decisions. Oh, it's white and black list, right? So if you look at the OpenFlow model, the only forward packets based on the flow you put into the switch. So it's kind of white list, but they also have a bunch of security concerns, and they use that OpenFlow to implement the blacklist as well. They have a complete control over the topology and to be able to scale. And they want to have the control over the architecture for controller and a bunch of other things that we'll talk about. Okay. Maximum visibility. So I remember the meeting with the CEO, he sit down with us, right? He said, the CEO used to run big call center with incumbent equipment, right? So when the network is down, he said there's no one can tell him exactly what happened to the network, right? The entire support staff, the staff, technical staff on the incumbent company look at the network, but no one can tell him exactly what happened to the network. Okay. So then he spent 1 week after the network is recovered. He spent 1 week sit down with the IT staff or network staff, go through every command, CLI command they use to configure the network. Right. So he come to a conclusion. It's amazing with that complexity, the way they configure the routing. It's amazing that it will even work. Okay. So now he started this new company. This Greenfield is a startup data center company. So one of the decisions he made is he wants a complete visibility of the network when switch make decision forward packet and when not to forward packet. Okay. And he wants 100% automation for the network. So those are the kind of the design goals that he had, right? So, okay, so starting with the constraints. So we have 200 plus customers, right? So after the customer buy the switches, after they use it, goes through the initial cycle, the first thing, or a lot of time they ask, well, what is the TCAN size? How big TCAN table I can put in? Right? So my standard answer is, depends on the model. So for a 10G switch on Trident Plus is 1,000 entries. On the 1G switch, using the Firebolt or Triumph switch is 2,000 entries. We have a Trident 2 coming up, is 2,000 entries. Okay. So usually there are two responses. Most responses, well, that's not enough. I said, I know that's not enough. Right? But this customer, I want to pick, this customer is, they understand all this constraint, but they say, David, how do I work around this? Right, so let's design a data center with all this constraint. Let's work through all this constraint, see what I can do. Okay. So that's the first constraint, TCAM size. The next constraint is there's no open flow ASIC. Right? The open flow switch is built on top, let's say, the most common one, Broadcom platform. It's a layer 2, layer 3 ASIC. Right? So a lot of the open flow concept defined for the soft switch doesn't fit well with the ASIC pipeline. Right? So for example, if that's a typical pipeline, you terminate the tunnel, you go to layer 3 learning, you go to the layer 3 entry table to do routing, you go to the ingress ACL, then you go through the metering. I mean, this is a pipeline. So most of the implementation today, OpenFlow switches, they use ACL because that's a TCAM, which you have flexible, you can match on layer 2 and layer 3. That's what OpenFlow specifies. Right? Then you can do action. But there's a bunch of features that define in the OpenFlow model cannot be supported. So those are really kind of serious constraints. Right? So multiple table, for example. I mean, because the limited TCAM size, you like to have the multiple tables so you can reduce, you do multiple lookup, so you can reduce the number of rules instead of one flat root. But multiple table is very hard to support because TCAM is one regions, even come with slices, but the lookup is just one lookup. Right? So for example, so one question we solve in this deployment is how do I, for example, this is one of the 100 issues that we kind of work together. So how do I forward based on, for example, destination IP address, but at the same time I want to do queuing, right? So each destination IP address go to a server, I want to have 8 queues, but in the current OpenFlow, the way you specify rules, then if one destination IP forwarding, you have 8 queues, you do 8 set queues, and it will be 8 flows. How do I solve that issue? No possibility to act after flow mark. So that's one issue. Actually, we submit a feature request to ONF because today, once you do a flow mark, install a flow, you don't have an act positive acknowledgement. If you look at the spec, you basically assume you get there and get installed. But if it failed, then you get a notification. So we have to continuously do flow stat to retrieve the status to make sure the flow is installed correctly. Right? So that caused some issue because initially when you bring up the controller, when you bring out the OpenFlow switches, most of the cases you install a bunch of static flow, right? Based on the things you know how you want to route. So then some of the flow depends on whether you install the previous flow successful or not. So in this model, in the current OpenFlow 1.3, writing a controller logic is very hard, right? So you do a chunk of write, then you have to go figure out what the status is and go into that. So it's very hard to do a kind of state machines that handle this type of scenario. So all these constraints, when I say starting constraints, when we work with the customer in April 2013, that's the status of our switch. I think our switch was 1.6, 1.7. Today we're in 2.2. So I will go through kind of all the things we did to kind of improve all this constraint to deployment. OpenFlow version 1.2 we support at that time. So there's a group table. So if you have aggregation layer and top of rack configuration, right? So the port, the uplink from the top of rack to the aggregation layer, you want to have, normally you configure as ECMP, but in a layer 2, layer 3. But OpenFlow, really, there is no kind of ECMP concept. At that time, when there's a group table, if you use a group table select type, it's kind of emulate what ECMP function is. But if you look at the switching pipeline, ECMP is the layer 3 functionality handled in the layer 3 pipeline, not handled in the ACL TCAM. where you program rules. I mean, you can fake it. I mean, we did something, but it's not very efficient. It wastes a lot of flow entry. Fast failover. Once you configure ECMP, you want to do load balancing, because from top of rack to aggregation, usually you have a redundant link, so you want to do load balancing. When one link is done, you want to do a fast failover. It's all the features that traditional switch that support that make it work. But in OpenFlow, we need to make sure that works on the OpenFlow, this simple control model as well. Zero touch provisioning to make it production, so you want to be able to put the box from the stockroom, put on the rack, and power on, so you download the software and upgrade. Metering, so all those features that when they started, or when we started with them, not there. But the point I want to make is, you want to go into production with OpenFlow, you do believe OpenFlow, you have to go through kind of a step by step. You have to work through all the constraints. You have to design that. Okay. Now, so the first thing is scale. Okay. So, I mean, we spend a lot of time to figure out how to scale with OpenFlow with limited TCAM entry. Okay. So I can jump ahead though, even though it's 1K or 2K flow entry, but we did a bunch of optimization. So now on the 1G switch, we can do 4,000 entry, but still not enough. Okay. So how do you scale under the OpenFlow constraint? So that's actually the first thing we went over. I remember they went through their own design, then they asked me to go do the reveal. Then they have this whiteboard has 7 layers of multiple tables. They have 7 multiple tables, right? They have everything designed out, how to do each filtering at each stage, right? So when I go there, I look at that, so I say, can I have an eraser? I erase from 2 to 7. I said, that's the only table you have. Let's figure out how to work. So scaling is probably the first one you have to go through in your data center design. Okay, so what does that mean? So now I talk about the flow entries, number of flow entries, right? Then because the white box, so there's a limited number of ports. So let me just give you a sample configuration here, right? So you have the core layer, you have the aggregation layer, you have the top of rack layer. So top of rack has 48 port, then going to aggregation. Aggregation has 48 port. So then going to core, connect to multiple data centers with multiple NG port. So the first thing we did is we define, well, the first thing is we kind of reach a agreement that you cannot scale your architecture like the traditional layer 2, layer 3, where you want to grow indefinitely with the fabric. Right? So OpenFlow, you can build it. Excuse me. You can build a fabric, but there is a limitation on how to scale. Okay, so once we reach that understanding and conclusion, then the thing is very easy. Okay, so basically, we kind of define a scaling unit with the focus on aggregation. So aggregation layer, 2 aggregation, each aggregation, excuse me, each So each aggregation layer support 12 racks. So and each rack has 2 top of rack switch with 40 servers. Right. So then they're 48 port, their outer port, and they use that to connect to their management network. So each server, each switch, their management port is connect to another IPMI network with another switch, and switch connect back to the top rack, so they can learn the management address. They can do a bunch of stuff. Anyway, so this is a scaling unit in terms of how you grow based on the flow constraint. Okay, now how do you grow? So if that's a scaling unit, let's say 12 racks, right? With 2 aggregations. Now, you can build third tier fabric. I mean, you can grow that, right? But it's complicated. They want to keep it simple. So what they decided to do is that's a scaling unit. Then I will have multiple scaling units, connect them together through N by 10Gs links. Right? So they do the traffic engineering. So you can imagine this is one node. So this is one node for the scaling unit. Then what they do is, then they have a multiple of this configured in a topology. Okay, so in a topology, then between each node they connect through N by 10G links.
So David, if I understand right, you're saying there are 12 racks in one of these groups.
Right.
Is the topology of the Tor through the core layer a fat tree, or is it something else?
No, in this deployment, no. They did not go through that complexity. They just want to keep it simple. So basically, 12 racks. So, okay, so let me. So 40 server use up 40 port on the top of rack, right? Okay, so on the top of rack, on the top of rack, there's 4 10G port, right? So they'll have 20G, 2 10G port to each of the aggregation configured as the ECMP group for load balancing and fast failover. So that pretty much if 12 rack you do the math, is about, you use up 48 port, right? So each rack has 2 10G to that, right? So you have 2 top of racks, so use 4 the 10G port. Then so that each aggregation switch can only support 12 racks.
So in your customer use cases, right, or maybe even in this use case, how are your customers doing storage? Do they maintain a separate network? Was there any requirement for FCOE kind of situations? It seems like these switches only support Ethernet, no storage, right? No FC.
Right. So storage is actually connected to the switch as well through Ethernet link. So it's connected to
maybe it's all
10G. So I'm sorry.
Is it see in SAN typically we need the fiber channel connectivity, right?
Oh, so this one it is Ethernet. So come out at file servers, come out at multiple gig Ethernet or connect to the switch. So, okay, so now that hope that the math is clear. So 2 10G port per top of rack. So for 2 top of rack, take 4 10G port on the aggregation. So 48 divided by 4, so 12 racks. Okay. I mean, we could deal, actually we are in the lab, we are doing a factory configuration for another fabric, but the complexity there is a lot more. So here they want to keep it simple, right? So instead of using a factory, building a fabric so we can grow indefinitely, they say, I don't want to do that. I just want to have a very single unit, but I want to scale in a different way. So we'll have a limitation how they scale. So you can imagine if this is one node, then you can connect 3 or 4 of those nodes together, right? Form a topology. Okay, so here, so that's why I have one cloud. So one cloud means there's a couple of this node connected together. Okay. Now, how do you scale? So that's one unit, one topology unit. Okay, so there's a scaling unit. Then when you connect multiple nodes together, it becomes a topology. That's a topology unit. So now, instead of build a fabric, so this topology, flat topology, can scale indefinitely. They scale this way, right? Okay. So what does it mean? So that topology become a unit when they scale. So when they turn on, when they build more capacity, they put more customers, they need to have more, they want to scale, they do one cloud at a time. So it's all kind of pre-configured, pre-installed. That's it. So that's a scaling unit. There's no flexibility. Today you roll a rack to the data center, wire them up, and turn on the fabric. That's it. So they want to simplify the operations. So that's what they did. I'm not saying this is the best way. It's a very simple way that under the OpenFlow constraint. Okay. So that's why I have multiple cloud there. So once you have the scaling unit, you configure a topology based on each of the scaling.
So what's the over subscription level you have? 1:2 is it in this case? The
Sorry.
over subscription level that you have in this case, 1:2 is it?
Oh, okay. So the top rack for this data center is 1G. So 48 1G to 4 10G. So
Almost.
on the top rack subscription rate is kind of 1-to-1. Then from aggregation layer to the core, there is 48 10G and 4 40G. So they're over subscription 1 to 3. I'm sorry?
1:1.2. So
Oh, thank you. Okay. So anyway, so that's how you scale. Define a unit, define a topology, and you scale the entire topology one at a time. Okay, hopefully that you can get that concept. Then, okay, so on the core is also 48 10G, right? So, but from aggregation to core, you're not using all the 10G port. So those spare ports are used to cross-connect between each of the cloud, right? So give you that connectivity for, there's a three-dimensional traffic, it's not east-west, anyway. So inter-data center, okay, so inter-data center between core there, but core can talk to other core through this topology. Question?
So if you need more than 3, you want to scale a certain layer, how do you scale that layer?
Oh, yeah, you can go more than 3, but then it's not a mesh, right? So between each cloud or each that topology configuration, or let's say a ring configuration or square configuration, between the vertex, between the point of the ring or the square, there are fixed number of bandwidths go between that. Okay, so so you don't have a any-to-any connectivity, but you have fixed number of bandwidths connect from each of the topology, from each of the rings, or each of the square. So that's the second thing. After you figure out how to scale based on the application, right? Based on the application, based on the type of traffic, you have to go through traffic engineering to figure out the traffic patterns so we can define a topology or scaling configuration network. Okay? Okay, so once we defined the scaling architecture, and once we did the math, figure out traffic network, the next thing we do is, I won't go over the rule by rule, but the next step is really to figure out how do you do traffic forwarding in an OpenFlow data center. Okay, so that's the second most difficult part, the longest part that we spent on figure out how to route traffic. So what does that mean? If you remember, one of the criteria is they want to have full visibility of the network, right? So with OpenFlow, we can do that because whatever you installed on the switch to forward packet based on the matching action, whatever rules you put on to drop packet, it's there. So the question is, what rules you want to put in there based on the constraint you have on OpenFlow switches, right? How do you use, let's say, bitmask IP address to reduce the number of flow entry you want to do? Right? So there's a set of design needs to go into to design the IP address scheme so you can reduce the number of rules, right? So you can't have a way to assign IP address randomly, because if you do that, the flow entry won't be enough. Okay, so so the second step you have to go through is lay down. Once you have the architecture, you have to lay down all the things you would do in the data center operation, from IP address, MAC address, security, forwarding decision, between racks, inside the racks, going to gateway, going to internet, traffic coming back, how to prevent loops, how do we handle ARPs, how do we handle broadcast, how do we handle multicast, how do you learn, right? So you can figure out all the things you need to install on an OpenFlow switch, right? So I kind of did analysis, because we write a controller ourselves as well. Most of the time, you probably write a controller and handle 70% of the situation, right? Those 30% you don't know. And how do we handle those? Anyway, so just some of the example for the top rack rules, drop rules. Usually, we do drop first, right? So we drop all the things we know we don't want. We don't wait for the default. We just drop everything. Like in this case, IPv6, drop first. Okay. Then we do learning because there are a bunch of stuff happen in the network that you can pre-configure. For example, putting a new server, right? So the new server will send out, let's say, ARP, then you have to learn that IP address. Right? So the ARP SPA field will give you the IP address of that new server. But then you need to validate, right? Is it a valid server that's supposed to come from this port? So there's a bunch of learning you need to do. Then you want to learn all the management port because people want to come in, manage the switches. Remember, all the server management port and the switch management port connect to a layer 2 switch that will feed back to the top of rack switch. Right? So top rack switch will get a bunch of IP address from the management port and things like that. Then forwarding. So forwarding actually is the easiest part, but you still need to lay out, right? So when a new server is so in those topology, they will configure all the switches, all the top rack switch, all the aggregation switch in one unit going, right? Then they will plug in the server. Then, for example, when server plugging, you need to set a rules, right? You need to set a rules to forward traffic from the server to internet, to gateway, to another racks, or to another server. Right? So there is a set of rules. Okay. So you see there. Do I put there? No, it's not here. Anyway, so if you remember the topology, right? So from top of rack to aggregation. So basically the rule is very simple. For packet coming to the top of rack, it's not in this rack. I will forward to the logical group I created, right? The select group. Because the select group is the two link, the multiple links going to the aggregation, right? So basically the forwarding decision is very simple. If the packet is coming here and going to another server, I will do local switching. If it's not, I will forward to the group that I created with ECMP feature going to aggregation. I will just go to the aggregation. Now aggregation will make a simple decision, which rec is going forward to. Right. Okay. So that's kind of an example, but the point I want to make is when you design data center, use open flow switch, that's the next step you want to do. You want to lay out the entire data center, and at each stage, you want to define all the forwarding rules, and you want to go optimize. Okay. Again, even though we optimize on the top rack 4,000 entries, the aggregation, the 10G switch is only 2,000 entries. Okay. So usually there's a set of drop rules. You want to drop, there's a learning, you do dynamic rule installation, and you do basic forwarding. So that's top rack. Okay, aggregation. So for top rack, with that architecture, about 1,600 rules, roughly, during testing. 1,600 rules on top of it. So we still have some room to grow. Okay, aggregation. Aggregation layer, actually, it's easier. If you remember that topology, really, traffic coming from top of rack is a very simple decision. Look at the IP address or the mask, decide which rack it's going to. Right? Just forward to the top rack of other rack. Now, if traffic is going out, then forward to another group going to the border, going to the core. So they will make those decisions. So the entire forwarding decision is breaking into segments. Right? So you have to lay out the network at the top, rack aggregations, and the core, and figure out how you optimize routes. Yes.
So at the aggregate, you have a less specific rule, and at the TOR, you have a more specific rule. That's what you're trying to do, right?
Yeah. So at the aggregation layer, it's all what the ECMP group, right? So the moment you see this address is target for that rack, I send it to that group.
So my VM migration is within that set of racks.
Okay, so VM migration gets similar treatment like the IPv6. So right now there's very small VM migration happen, right? If I tell you they don't even believe VM, it's waste. Anyway, so they do run the KVM and other stuff, but the VM migration, I think, I don't know. I mean, from their perspective, there's no need. Right, so, but it doesn't mean it cannot be handled. So when you move one VM to another VM, depends. So you can learn. So the rules I talk about, right? So, and the controller will learn this new VM, move from here to there. Depends. If you keep the same IP address, then it's a different set of learning. If you have a new IP address, you start a new VM with a new IP address, and you learn that IP address, and you do a separate route. So those things can be defined, can be handled.
I have a question. So who does the optimization here in terms of the TCAM entries and what flows get programmed? Is it from the controller level or is it from the switch?
Okay. So there are multiple levels. So TCAM optimization I talked about to go from 1,000 entry on the 10G switch to 2,000 entries done by us.
Okay.
Right, so,
Us is the switch.
by the switch by us. So the TCAM optimization is really because it's a fixed size TCAM, right? So each size is multiple. You have 2 entries. So if you don't need to use 2 entry, you can use 1 entry. If you just do IP-based forwarding or MAC-based forwarding, then you just use 1 entry, so you can double the size. I mean, it's not magic. You just need to figure out how to do it. Now, the rule optimization, the flow optimization actually needs to be done between vendors and the customer, work very closely together. I mean, the design of the whole data center requires kind of a teamwork because you really need to understand how the switch behave, before we can write controller applications. So we kind of work together.
So, are you able to reveal, was it your controller? Did you mention that, or are you able to reveal whose controller was fed with the PPI switches?
Okay, so controller question. Let's wait until later. So, where was I? All the sequence. Okay, aggregation layer. So aggregation layer, like I said, the decision is very simple after you drop everything you want. Then the forwarding is really based on the IP address and the mask. The mask, the bit mask is a very useful feature when you design rules because it help you reduce number of entries if you use it correctly. So basically just forward to different groups. So all those groups, 53, 55, they are just the open flow group, the select type, or we call ECMP, that we implement. So,
is there any reason why some of the flow have lower priority in this case?
oh, okay, yeah. So, okay, so priority is kind of tricky thing. So yeah, so you also want to define priority. So drop is always the first priority. Now forwarding decisions. So in this case, actually the priority doesn't matter because there's a unique match. But come to, if you have rules that you match on similar field, then the priority become a important consideration. You want to make sure that the packet coming match the high priority one. Okay. So in this case, actually, because I kind of just randomly filled in some priorities, I just want to make it different. So, okay, so let's see. Top right. Okay, so top right. So port 49 to 52, that's the aggregation port. So if you look at this rule, you'll know right away. Those are the traffic coming from outside, going through aggregation and trying to go into the server. Right? So coming through the uplink 49. So port 1 to 48 connect to the server, and 4950 connect to the aggregation layer. Then when you send that thing, because all IP based, so you need to fill in the correct MAC address. Otherwise, the server will drop it. You want to fill in the destination MAC address. Okay, so so I think once you have done those two steps, I think the most difficult part of the data center design, I think it's kind of behind you. Now you need to verify the whole thing works, right? So then you need to find a controller and do that. So we'll talk about control later. But before you reach to that point, so vendor like us, we did a bunch of stuff to make sure the switch is production worthy, right? So like I said, we did TCAM optimization. So now we support 2,000, 4,000, 8,000 entries, depends on what model you use. We implement a group select, ECMP. Okay. If you look at OpenFlow standard, there's a group function and they have a type called select. And to implement ECMP, TCAM won't do it. So we have to figure out a way to enable the layer 3 feature. So even though the pipeline processing is layer 3 and TCAM, so we spent some time figuring out how to enable that feature for the ECMPs. And to us, that's one of the most critical features to enable data center deployment because you do want that load balancing and the failover mechanism to be there between the aggregation and the top right. Metering wasn't there a year ago. Now we have it. It's good, but the meter is a feature in the TCAM, right? So if you have 256 entries in TCAM, you have 256 meters. So if you use meters, but meter only gives you kind of number of packets. It won't tell you ingress, egress, packet count. So there's certain limitation, but metering is still a very important features that allow you to monitor the behavior. Testing the whole controller framework and
I Are you supporting hierarchical meters?
No, we treat it like the IPv6. So. No hierarchical meters. Pre-configured queuing. So, like I said earlier, so if you do destination IP forwarding, and the packet coming to that destination IP has different type of priority, right? So because you have it into different applications, database application versus VoIP applications versus other. They want to have a queue, just do a set queue, but it's very hard to do a set queue with the TCAM limitation because then each destination you have to have 8 entries or more. So then we figure out a way to do pre-configured queuing so you don't need to waste the number of entries. NLDB. So some of the feature here I discussed is not OpenFlow specification. It's the feature that we kind of implement to enable production. NLDB is a very critical feature. So actually a couple weeks ago, I was in China and they called me and said, well, there's no packet going out. I said, well, did you drop everything?
I think so.
That's the first question I had. Is IPv6. Okay, so I'll tell you what happened. So they forgot to install a layer 2 drop rule, okay, for a certain Ether type. So when they turn on full traffic and doing testing in the actually in the lab, so what happened is, because you did not specify the drop rule, and in the OpenFlow spec, what they say, they forward to the controller. Right. So top of rack, I just ran in a pic. Top of rack send packet to aggregation layer, and aggregation layer forgot to put in a drop rule. So all those packets going to CPU. But between the ASIC and the CPU is the PCIe bus. So it has a limited bandwidth, right? So when they start to flood the CPU, because the CPU connects to the ASIC on another port. So the ASIC say, hey, this port is congested. And guess what happened? They do flow control. So the flow control enabled to send the flow control over to the source, which is going to the top of rack. Right? The top of rack send packet going to aggregation layer, but aggregation layer forgot to process that packet, flood the CPU. So flow control enabled on the top of rack. So now all the packets, because the traffic, so they keep sending flow control, so top of rack, the packet buffer is full. Okay, so when the packet buffer is full, nothing can go up. Okay, you can look at the entire OpenFlow standard. You can look at entire SMP MIB. Well, we don't even support SMP MIB. There's no way you can figure out. Right? So what do? You have to look at the counters on the ASIC chip. Right? So there's a set of counters monitor the packet buffer. Right? So you open up the debug window for the Broadcom chipset, you look at the register, the packet buffer is full. Why the packet buffer is full? Then you trace back to figure out, there's very simple. There's one rule, drop rule did not put in there. Okay. So what is the analytic DB on the switch? It's a database that we implement that capture all the Broadcom registers. I don't want to say all the registers. I mean, the counters, important counters. Let me put it this way: all the important counters. And we filed a pattern that we can capture the counters at 1 second interval. So analytic DB export the important information that to the controller or to the operator, so you can figure out what's going on. Okay. So there's a bunch of other stuff. I think OpenFlow, programming the flow, like I said, it's very simple. But how to figure out when things not working is most difficult. So there's a lot of opportunity for people to build tools to solve those issues. Zero-touch provisioning, I talk about event reporting. switch inventory. Event reporting is important. If you look at the OpenFlow standard, they give you certain event or status change, right? For link up and down, flow removal, group table deleted, table mismatch, table miss event, and a bunch of stuff. But then there other stuff it's not defined. The environmental stuff, right? So the CPU usage, well, OBSDB has that. CPU usage or the fans and temperatures and other stuff, right? So those event reporting is critical for production because they need to monitor that. But we don't want to take a traditional SMP. You put SMP agent on the switch, then it's waste. The SMP code is probably more than OpenFlow code. So we designed a set of table using the OBSDB structure to report those events. It's configurable. You can configure the threshold. If it hits the threshold, generate event, you can define severity. So you can do traditional alarm processing. Right? Switch inventory. Oh, sorry.
So you have your own schema for OBSDB?
Extension. Extension to OBSDB. Actually, I'm writing something so I can submit to Dave Hood, the architecture group, as an extension. So it's not in competition with OF config, but we think it's a simpler way of doing management of the switch. So let's see where it goes. There's another.
Have you thought about any type of structured log that you would export, either be to a file or be a syslog or something like that, and that you could actually tune to diagnostic information?
Yes. So yeah, syslog function is implemented. So the configurable event reporting, those events, you can configure a receiver to receive those events, or you go into the syslog, then you collect those syslog.
And are you doing these detailed attributes?
Oh, the analytic DB?
Absolutely.
No, not in syslog. Those are a different mechanism to export those data. It's a lot of data, right? So let's say about 100 counters per port, right? Each one will keep kind of 8 byte. Then 52 ports plus some other stuff. There's queues and there are other things it'll capture. So if you want to capture every second, it's a lot of data. So
Yeah, I would assume that you didn't want to do that. You probably want to aggregate something or different levels of aggregation. So you would turn on no aggregation if you wanted to get deep. I could understand it, which is a problem. But having some aggregation may be good enough.
So I won't call it aggregation because the counters export kind of flat, right? But then there's a select mechanism allowing you to select a subset of counters.
I agree. Let me rephrase that. Useful statistics, useful analytics that you could embed in there so that you know where a table's getting too big or something like that. They give you some indication ahead of time downstream.
Oh, okay.
I mean, those are analytics that I think that are very simple that you could get off a switch like this and be able to toss it somewhere.
A good point, right? So if you want to do alarm suppression, for example, and things like that, right?
Yeah,
So
exactly.
yeah, so those, yeah, so you can configure those and export to your network management system, and yeah, so they can do that up. But the question is, where do you do that, right? So I have one slide talk about the network management. We can discuss that.
Sure. I would hope that would eventually get to be a standard within for diagnostics. Because I don't.
Yeah, so that would be a
I'm trying to
good
figure
idea.
out how do you fix this stuff when it breaks?
But I agree that's a good idea.
So the situation that you ran into, are you working that into some future solutions so the customers not gonna call you and find out that they have source control? Flow control?
Oh, your flow control. Oh, yeah. So that's what Analytic DB provides. So it's a flat data. We haven't had time. We haven't had time to build next level tool. But there are a bunch of ideas we have that we can build a bunch of stuff that help people to do diagnostic. Yeah, so that's the number one key issue. Switch inventory, for example, plug-in inventory. Right? So you want to do the optics inventory, so that's important information for you to figure out. And crossflow mode, actually. Okay, so let me spend a bit time. So interworking between OpenFlow and layer 2, layer 3 network never been defined well, right? So in OpenFlow's spec, there's this kind of ship at night hybrid mode, right? Everybody has a different interpretation of hybrid mode. And we had at least 3 different hybrid mode implementations that we released to customer and never go anywhere. So the only thing I want to mention this is now we have a new implementation. Whoever interested in this, buy our switch and try it out. But basically, instead of ship at night, that the layer 2, layer 3 stack and the OpenFlow stack, that they don't talk to each other, we kind of design a way to have a port-based configuration, so you can have cross-flow mode, we would call cross-flow. So you can have an OpenFlow network with this set of port, then those will be controlled by the OpenFlow controller and the TCAN rules. And some of the port you can configure with pure OpenFlow control, that's called cross-flow local control. Right? So the local control layer 2, layer 3 stack does not intervene with those packets. Or you can say cross-flow local control on, which means that's where the interesting part come in. They will go into TCAN and also go into the layer 2, layer 3 table. Then you have the legacy network. Okay. So it is a kind of complicated configuration. We're playing with it. We have customer playing with it, but I don't know where it's going to be end up. But that's, again, we kind of developed this feature because inter-data center forwarding, there's many options. You can do static route, you use OpenFlow, that core layer, or you can enable, for example, BGP, the broadcast route between data centers. So these features we developed to do that. Then other solutions, you run BGP outside, like on the controller to terminate all the BGP route, then figure out how you route traffic.
What does it mean? Because I remember you said like you want to eliminate multicast and broadcast, but then you have the middle box that is legacy overlaps with.
Right. So in the pure OpenFlow design for that data center, we eliminate all the broadcast and multicast. But if you use cross-flow mode, then yes, you will get those broadcast packets. But hopefully those packets coming will go through the port that has either local control on, or it will go into the layer 2, layer 3 stack, or go into the legacy port. But if you go to the TCAN port, we just drop them like IPv6. Right? So we just define a rule with F or F and we just drop.
These ports are all like PKI ports on your switch, or?
Yeah, so this is in one switch. That's a good point. So the cross-flow mode will work on the switch, on the same switch, so allow the two networks to work together.
So who decides what to send what? Is the controller like essentially making a decision? And
Okay, right. So packet coming through legacy network, it will hit the FIB and the forwarding database and route table, right? So packet coming, they will get routed there. If you look at the pipeline, layer 2, layer 3, then the ACL, and then the TCAN. Now, packet coming from OpenFlow will go into TCAN, get routed there. Right? Okay. Now
that's what I'm saying. How do you know it's not from open?
Oh, because you define the set of port. It's port-based.
Okay.
So this time we implement port-based. Before, we implement VLAN-based hybrid mode. And the packet coming on the cross-flow port with local control on, then you will hit both. Right. So then there's different ways you can do that. So then the TCAN. Right. So don't use Because I have to support you. Yeah, so we'll hit layer 2, layer 3, then TCAM, but in this way, TCAM has precedence, right? So one application you can do is, for example, you can identify special type of flow that you do special processing, because once you hit the routing table in the layer 2, layer 3, you just get routed. But then you can install open flow rule for certain things in a routed network, but you want to split them out and perform special processing. That's one application that we can think of.
Do you need to maintain any consistency between the TCAM and the route?
Yeah, so when you do this, yeah, you have to know what you're doing. You have to know there's no overlap, right? So the rules, the route, because even legacy packet come in, going through route table is still HTTP, because that's the switching pipeline, right? So you have to design your rule carefully, make sure you don't have that conflict. Anyway, so it's an interesting area that we have customers using it, and we'll see. Maybe a couple months later we'll do a different implementation.
So the crossflow basically will go into the TCAM first, and then if it doesn't find a match or some sort, it will go to the other credit table.
Yes, for the crossflow, yes, we're going to actually for pure TCAM, for pure open flow, right? Crossflow local control off, those are just going to TCAM.
Yep.
For crossflow local control on, they will hit both table, and you want to make sure that you don't have conflict.
Okay, with no priority.
TCAM always take priority.
So
Okay.
If there's no entry, it will go to the SM controller. You can assume like proactive or reactive type of.
Oh, so yeah,
I mean,
so
you want to explain, like,
yeah, so the TCAM behave like this, or open flow specified like this. So if you don't have an entry for default drive, right? So if you don't have an entry to capture the packet, it will get dropped if you don't have a default rule there. But then if you want the packet going to the controller, you need to specify that. So for example, you have a low priority 1 wildcard rule and going to controller. But you have to be very careful for packet to control, because there's a limited number of packets you can send to controller. It will flood it. It will flood the CPU. But now we implement some mechanism to make sure it won't happen, but still. Design your rule carefully, don't, yeah. Controller. Okay. So controller, okay, now that you went through all this design cycle, then now you understand everything you want to implement in the overflow controller, right? So then you do a controller. So they decided to do a in-house development. We kind of went back and forth many times, and they talked to many different controller vendors, right? So, but none of them, the problem today, from their perspective, not my perspective. So it's hard to find a controller vendor that really understand the data center operation or that specific application, right? So how do you write a controller for this customer that do their bread and butter data center operation by another company? I mean, the logic doesn't work, right? So especially this CEO, he wants complete visibility, complete control over, so that he doesn't have that problem that when things not working in the network, no one can tell him what happened. So this company decided to build their own controller. Okay, so then they did not use any of the controller frameworks. So they have a very stripped down version, the OpenFlow protocol parser, and build everything themselves. Okay. And guess how long it takes? Less than a year. I started working with them in April, now going to deployment. Okay. To me, I kind of stepped through the whole development cycle with them. I mean, to me, that's really a success story, because they understand their application logic, and they implement their own controller, and they did not take any controller framework. And the development time is really less than a year. Very few people, a handful of people, less than a handful of people.
Quick question, I see OVS-DB here, and you also mentioned that you have OVS-DB. So can you comment on why OVS-DB versus OF config? What was the reason for going with OVS-DB versus choosing OF config?
Simplicity. Very simple. Yeah. Actually, we will make a kind of create a bug report issue for to the ONF to use OVS-DB to support some of the menu functions. It's very simple. We control it when we do OVS-DB, right? So instead it goes through the consortium. I used to work at telephone company, so I know how the kind of standard process works. Anyway, so and they have a very smart way of implementing the controller. During the lab, they run centralized. Then in deployment, they run distributed. Harry would love this. It's a microcontroller. you blog about. It is a very thin layered controller running on the switch actually in deployment. Right. So to eliminate some of the issue you have with centralized controller, redundancy, most of the problem between the controller and switch is that connection, right? So they do that. I'm not saying that's the best way, but that's the way they choose. In progress, that's the OVS-DB interface we talked about for inventory, event reporting, and other functions. We like to put in, other than simplicity, is then we don't need to add another interface, right? So we have an open flow interface, we have an OVS-DB interface, so it's really, if you look at all the management, it's really just a table of data. I mean, open flow protocol can be defined with OVS-DB as well. You don't need a protocol. So that's the decision. And after this, we have a bunch of new ideas on how a controller framework could be. So if anybody here wants to build a controller, come talk to me. Okay. Yes?
Do you think for the event reporting there needs to be another channel for telemetry to get the information within the switch to the controller to make the correct decisions for analytics?
That's a very good question.
So you have a control plane, you have a data plane, what about a diagnostic plane?
Right, so, but the question, do you want to put that into the controller? I mean, controller, so there are different philosophy
The
of
controller
controller.
could be a consumer of it, all right?
Yes, okay. So if your definition of controller is broader than just open flow control, yeah, I would say yes. You need a controller in the network to take those information to make decisions, right?
Or expose that to the regular controller so it can make decisions.
Yeah. So, yeah. So that part is nobody really worried because no one has gone through the first part to program the switch here. So, right, so they're putting 10, 20, 100 flows and in the lab. So who cares about what diagnostic? Right, so until people have gone through this and go to deployment, then they will ask the same question you ask: how do I manage this network? What are the data I want for analysis so I can keep the data, can keep the network working? That's the design. Right.
As
So-
well as modeling for external what if analysis. If I decide to grow here, to do it.
Yeah. So I'll come back next year and tell you all the things that they need to do diagnostic.
That's still the same path of V6, right?
So, okay, any more controller question?
Do you actually keep state on the thin, lightweight controller on the switch, or is all the state kept in?
Yeah, they are states.
Can you talk about your general strategy for how you deal with consistent state across the various?
Okay, so between multiple switch, there's no need to maintain consistency. Right? So the controller on the switch keep the state consistency, like a state machine. I mean, mostly for flow mod type of operation. They want to make sure that the flow installed is correctly based on the previous installation status. So that level of consistency is maintained. But then there's a synchronization, okay. There's a synchronization between the microcontroller, actually a centralized management system. Okay, because that centralized management system needs to push set of things to the controller. So there's a very smart way of implementing it. I can't reveal too much, but there is a centralized intelligence, and there's a distributed switch intelligence on the switch, and there's kind of orchestration coordination between those. Right? So it's a big state machine in partition into centralized network level and the switch level.
My understanding, the switch CPU is not that powerful because they want to put like a microcontroller inside on the switch. It must be a very light.
Yeah, it's very light. Most of the stuff is kind of static, proactive type of provisioning, right? So once it's configured, you just monitor the event coming from the switch. The dynamic, the reactive event there, but it's not that much. So let's see, what was one issue? Oh yeah, so like you said, the CPU on a switch is not that powerful. So when they put the controller running on the switch, and you get timeout a lot because the hello message did not get processed because it's a single thread implementation. So during initialization time, you put in, let's say, 500 rules, and the hello did not get handled, so the controller keeps timing out. So they have to break that into chunks, things like that. But then a multi-thread implementation will help. Any other questions?
So in the centralized part of the heavyweight controller, so is there a single one or there are multiple with the scaling units that you mentioned earlier?
Okay, so yeah, it will be multiple ones for redundancy purpose. Yeah, but right now I think, I don't know. But then because it's distributed, so the redundancy required for that centralized, it's not that critical. It depends on how you partition the function. It's very seldom for the controller on the switch die. I mean, it's very simple set of steps, and you just keep running that. But redundancy required.
And also in terms of scalability of that, I mean, if the all units talk to a single one, does it scale?
Right. So then, then the controller, they have their own kind of intelligent way of doing controller level coordination, right? Because they have multiple data centers, and usually the controller for the local data center is run inside the data center. Then how do you coordinate between multiple controllers? So I mean, there are all kinds of schemes that people do. But they develop their own scheme. And very smart way of doing that. Okay, cool. Any other question? Oh.
Yeah, what in this particular use case, what was sort of the percentage of proactive rules versus reactive rules? Can you talk about that?
I think it's about 60-40. The reactive rule is, for example, when they're putting a new server, or when they learn a new IP address because some event happened, so they will install a set of rules. So that's the most common event. Of course, there are other stuff like when the port is down and link failed and things like that. Software upgrade. So they have a very good scheme to do software upgrade for the switch and their controller. So I would say 60-40.
And the proactive programming is, as you talked about earlier, mostly based on how IP addresses are partitioned in the different
the forwarding, right? The part that you know how you want to do forwarding, what packet you want to drop, and what things you want to learn, what type of packet you want to go into controller, things like that. Okay, so network management, SMP, so I put a question mark. If it's needed, because existing infrastructure support SMP, where should go? So we've been actually discussed that internally. I really want to put on the switch, so how about controller? The controller control all the switches, get all the events. There's the controller, so in this way, controller is a broader definition, not just OpenFlow controller, right? So it's an overall controller. Should we put on the controller, so generate, like that gentleman said, aggregate all the network management information at the controller level and send it to the network management system. Inventory, event reporting, controller management is another topic that the moment you have controller outside the switch or control panel of the switch, the controller itself needs to be managed. So we are working on that. Conclusion. Okay, so I kind of went through the whole design cycle. So OpenFlow cannot solve all the issues. Right? So you have to look at your application. You have to go through that design process, understand your application, and do the scalability, figure out the forwarding rules. Then you decide. Then you can make a decision whether OpenFlow fit or not fit. Right? Now, of course, work with your vendor choice is very important because OpenFlow is still new, even though we always implement based on OpenFlow specification. But there are things that you need to understand how the switch behaves before you can write your controller, because otherwise it's hard to anticipate the behavior on the switch. I work with a couple customers, so this one is in deployment. We think there's a couple customers will deploy this year. All the OpenFlow applications need customization. It's very hard to find off-the-shelf applications that will work. They just, all my customers go through that and we all decided it's very hard, right? So all OpenFlow control applications require customization. If you don't have the domain knowledge how the operation needs to run, it's very hard to write control. So I think that's a major issue today that we see. A lot of people buying our switches, but very few deployment. Right? So we can't sell the switch, even the switch works perfectly, except IPv6. But we can't sell a switch because no one really can develop a controller fast enough. Without controller, it won't work. I mean, you can program through this OVS CLI, but that's just for that. So we're trying to address that ourselves. We're trying to collect all the knowledge we have based on the customer deployment and trying to provide a framework to allow people to write a control application faster. Scalability has to be designed. I kind of went through that. You can't scale indefinitely. Automation of the whole network management, configurations, visibility, because the template, the rule you define is there, so you should know exactly how it works. And to save the OpEx a lot. They don't have this customer, they don't have a networking staff to manage a network like a traditional network. Right? So the controller they develop actually handle network management function. It's the same set of staff that managing servers, managing customer services, that manage the network. Very few people. Controller is still the key to OpenFlow deployment. So that's all.
You didn't talk about what kind of CPU do you have, how much memory, is it a
Oh, on the switch? On the small one, it's a single core Freescale. On the 10G, it's a dual core Freescale. I think it's 1 gig memory, half a gig. How much memory do we have on the switch? It's even my customer doesn't know. I think it's half gig memory.
So from the level management, how can we do those like a performance management, how we monitor the port or the CPU utilization like what we usually does in IP network?
OVSDB.
That's the only thing.
That's one way we're implementing. So we define a bunch of tables. I mean, OVS-DB originally has the CPU usage already. If you look at the OVS-DB schema, it has the CPU usage. It also include VM, stuff like that, but like inventory and those, it's really a simple table that we populate, and you can just take it, get it.
So on your slide about network management, you had S&P and a question mark, and you kind of threw it out as a question, but how would you answer that question? Do we need S&P?
No.
Because-
We like IPv6, just drop it. You don't need it.
Well, as you pointed out, if it was on the switch, it would be a lot of code on the switch. I guess that's one of the.
So if you really do want it, because the infrastructure is there, right? Then I would say put on the controller. So you can do all the things like alarm suppression for a group of switches and report, set a thing to your HP OpenView or other network management system that need an SMP interface.
So you're not saying punt it to OVS-DB, that's just a temporary solution?
No, on the switch.
For the switch?
On the switch, you can do everything SMP do. SMP is a table too, right? Then it goes through a protocol to get it. So that's our implementation or our intention to do that. So SMP can be on the controller.
But your customers are demanding some level of SMP?
Yeah, we have customers who want, because they SMP, but I told them they don't need it. So let's see if they listen. Okay, yeah.
But when you say you don't need it, is the reasons for that, depending on where it's implemented, let's say it's on the controller, right? Is that because it doesn't provide the visibility that it needs to, like, you need to look into the switch and see the size?
Because-
Why are you saying you don't need it?
Because some of the, okay, on the switch, because some of the data that's important for OpenFlow diagnostic, it's very hard to get it through SMP walk and stuff like that. So on the switch, we like to export those data through a different mechanism, OVS-DB plus others. But then the SMP interface, in my mind, maybe controller is better place to do it. I mean, that's just my view. So,
Is it the case that the PK8 switches support S-Flow?
I'm sorry?
Your switches support S-Flow?
S-Flow?
Yeah.
Yeah, S-Flow and F-Flow supported.
So in which case then some of these questions about visibility could actually be answered?
Oh yeah, so if you want to do so if you want to use S-Flow and F-Flow to get visibility on the flow level, yeah, you can get it. But there are other things you can't get from there.
Well, for example, with S-Flow, you're also getting the standard interface counters.
Oh yeah, so those things we
So all of
support.
those would be
Yeah, the collector interface you configure or send there.
But unfortunately, it's sample.
So, can you comment?
But the counters are.
Can you comment briefly about the administration and maintenance overhead of the network that is deployed? Administration and maintenance.
Oh. Administration of the switches.
Yeah.
The
routine IT administration, things go wrong, needs to change or manage downtime and all those things. So what
right. So there's a major portion of the administration is done manually. Okay. So it could be added into the controller software to do automation and things like that. But inside the data center for that application, the administration requires actually not that much. It's a very simple operation.
I just want to know whether for this one, is it just a brand new deployment or do you have any case that just talking about from the migration from the legacy IP data center level and move to here? No, just brand new.
In your deployment, the customer, did you have any operations and management kind of protocols running to kind of make sure that there's always service assurance or connectivity between different devices?
They do. They have.
Do you know which one?
Can't tell you. I mean, they develop their own kind of management protocol to do that. So they want completely different.
Can you talk about how easy is the troubleshooting in an OpenFlow based deployment compared to traditional deployment? For example, two hosts are not able to talk each other. So where do you
Oh.
start?
Right now it's kind of hard. You have to understand the switch. I mean, first thing you do a dump flow, dump all the flows. But if you have 1600 flows, then it doesn't help you. Right? So to figure out what's going on in the network, to get that visibility, right now the data is there, but the analytic tool is not there yet to help you make that.
So where is the most common point, at the control side or at the parametric switch side? In such case?
Both. The controller will make certain mistakes, right? So, but then the controller mistake, then you end up you have to go to the switch to figure it out. So next year I can tell you. Just go into production. Okay.
David, you mentioned about controller, right? Like what is required of the controller? You mean the controller application? For the application?
Okay, so it's a good question. So if you look at the way today controller application is developed, right? So it doesn't matter what framework you take, you start writing code. Right? So you do Python or Java. You write code, you do a build, you do a test, but you won't have an environment to test large scale deployment. You test, you release, you put on the controller strings, you test. Most of the time you handle maybe, we use this 70%. You kind of figure out 70% of scenario you can handle in the logic you put in the controller. So that 30%, every time you release the code you put in the network, it happens 1% at a time. So you have to do it 30 times. So every time you find a problem, you have to go through this entire development cycle. Write code, change it, build, test, release, upgrade, bam, there's not an issue. So what do you do? So this is my personal view. So today's controller framework, the way you write the controller is very traditional. But in a new technology like this, it's very hard to go in production. So that's another thing. So we're thinking a different way of building controller framework to eliminate some of the issues we see in the controller development. Right? So most people, they're great Python, Java developers, but they don't have the domain knowledge the customer wants. But the customer may not have those programming expertise, right? So even they do, the IT staff, they don't know networking. So there's a gap in terms of how to get control application developed that can work going into production.
I have two questions. One is, based on you're talking about the framework, I think there are some researches going on with respect to different languages for writing the controller. We have like Pyrectic or something like that.
Yeah, I know. Right. Or OpenFlow 2.0.
Yeah.
Right, but yeah, so I don't want to comment on that, but there's a fundamental issue is how to turn, even a new language, how do you turn people who understand the application or the behavior, how to turn that into a set of code or language that run on the switch. Right? It goes through another compilation step, and it's another layer of visibility you have to worry about. Just like when you use multiple tables, but the TCAN only support one table, multiple tables get mapped into a single table, you won't recognize anything. You have no idea what's going on when the packet is not flowing based on what you want to do. So, will the compiler help? You will see.
And my next question is, you are not skeptical about SNMP, but how do you figure out about the net count and Yang combination? You're also skeptical about that also? It's also IPv6.
You ask me now, I say yes, I got V6, but let's see. I don't know. If all the customer wants it, we build it. It's not really my preference. Whatever the customer wants it, we will do it. So OF config is the right way to go. We build it. I mean, it's not hard.
Okay. Because it can also be in the controller, right? Rather than in your.
Yeah, it could be in the controller too.
Rather than being a switch level, actually.
Right. That could be outside.
The switch has to be asked down. That's what he said, right?
But smart people can make.
Oh yes.
Okay, good. So, thank you, everybody. You'll have my email if you have questions, and thank you.
So do you